Lesson 97 deals with recursive rules for sequences. Definitely think this is going to be one where you guys are going to have a lot of questions over the next few days, so I encourage you to ask them. Here we go, though. A sub n like this is used to represent the value of the nth term in a sequence, and we've seen that already. So a sub n is the value of the nth term. Now, if we have a sub n minus 1, that's going to represent the value of the term before the nth term. I'll just say the previous term. So right there off the bat, I can understand a little bit of confusion out of you here, but a sub n is the value of the nth term. A sub n minus 1, we're just going to say that that's the value of the previous term. Okay, so from there, let's do a quick review here. Let's say I give you a sequence, and we want to find the first, second, third, and fourth terms. So we're going to find the first, second, and third, and fourth terms. And let's say that I give you the value of those terms. The first, second, third, and fourth terms are 3, 6, 9, and 12. Could we write an equation to represent the value of each term? How do I find the value of the nth term? Hopefully you guys are looking at it and you see it, that it's 3 times the term number. So 3 times 1 would give us the first term, 3 times 2 would give us the second term, 3 times 3 would give us the third term, and 3 times 4 would give us the fourth term. Okay, that is not what we're doing today. Okay, that's rules for sequences. I think you guys could do that pretty easily. What we're going to do is a recursive rule. So a recursive rule for this sequence would look like this. We start out by stating what the first term is. The first term is 3. It's right there. So the value of the first term, that's what a sub 1 means. The value of the first term is 3. That's given to us. And then what we're going to do is write our equation like this. The value of each term is equal to the previous term plus 3. Now, where did I get that? Well, I can see in this sequence I'm just adding 3 each time. So that's why I'm going to say it's the previous term. That's what a sub n minus 1 is, plus 3. All right, so it's a lot thrown at you, but we're going to do it here a couple times. Let's go to example A. Write a recursive formula for the following sequence. Okay, first of all, I'm identifying that each term is 4 times as much as the previous term. And listen to the way I said that right there. 4 times as much as the previous term. That's what recursive is all about, basing things on. So we start off by saying that the first term is 1. The value of the first term is 1. And the value of every term is 4 times the value of the previous term. And we're done. So I got to figure out that it's being multiplied by 4 every time. And so I'm going to take 4 and multiply it by the previous term. And the reason we give the first value is that we can't figure out the second value unless we know the first value. So 4 times this 1 would give us the second term, 4. And if we want to figure out the third term, we'll do 4 times 4, which is 16. And if we want to do the fourth term, we'll do 4 times the previous term. 4 times 16 is 64. Let's try it again. The terms of the following sequence are generated with the formula a sub n equals 5 times n minus 2, meaning you take 5 times the term number and subtract 2. And 5 times 1 is 10, or is 5, minus 2 is 3. That's where the first one came from. 5 times 2 is 10, minus 2 is 8. 5 times 3 is 15, minus 2 is 13. And 5 times 4 is 20, minus 2 is 18. So we should already know how to do that, find these 4 terms given this. What we're going to do is write a recursive sequence. So with any recursive sequence, we always give the value of the first term. And there it is, 3. Value of the first term is 3. Then we have to figure out what's going on here from term to term. Well, it's each term is 5 more than the previous term. And again, 5 more than the previous term. Listen to the way I said that. You take the previous term, oh, and by the way, multiply by 5 means it's increasing by 5 each time. But you take the previous term, a sub n minus 1, and add 5 to it. And there's our recursive formula. Give you another model. One of the terms of the following sequence is 729. Write a recursive formula for the sequence and find the term that follows it. All right, well, before I start messing with the 729, let's write a recursive formula. First term is 1, and I can find every other term by, let's see what's going on here, multiplying by 3. Each term is 3 times as much. So I'll go 3 times the previous term. And the previous term symbol is a sub n minus 1. So there's our recursive formula. So if I want to find the term after 729, it's very easily. I'd just multiply 3 times 729. And that would give me the next term, 2,187. If I want to find the term after that, I'd go 3 times 2187. If I want to find the next term in the sequence right here, I could go 3 times 27. Okay, last one. Which formula below generates the terms of the following sequence? So 2, 3, 5, 9, 17, and 13. Well, looking at example or choice A here, I kind of got to go choice by choice. Choice A, the first number is 2, and the first number of the sequence is 2, so that'll work. Then they're saying the value of every term is 2 times the previous term minus 1. So we're going to do 2 times 2 minus 1, which would be 4 minus 1, which is 3. And 3 is the second term. There it is. So the third term is going to be 2 times the previous term minus 1, which is 5. And there's that 5. The fourth term is going to be 2 times the previous term, 2 times 5 minus 1, which is 9. There it is. And then we'll do 2 times 9 minus 1, 17. And 2 times 17 minus 1, which is 33. Okay, that's our answer. A is working every single time, so A is going to be our answer. But I'm going to check these other ones just in case. Now, this one says the value of any term is equal to 2 times the term number minus 1. Well, 2 times 1 minus 1, the first term, and 1, 2 times 1 minus 1 is 1, and the first term isn't 1. The first term is 2. Okay? So that rules out choice B. Then when we go over here to choice C, the first term works. There it is. They say the first term is 2, and the first term is 2. But let's check the other one. They're saying take the previous term and add 2 to it. Well, the previous term is 2, and I'm sorry, add 1 to it. So 2 plus, oh boy, I messed that up. I'm sorry. So they're saying take the previous term, 2, and add 1 to it. And that's 3. Well, actually, that does work. So let's try it again, though. So there it is. There's that 3. So let's try it again here. Take the previous term, 3, add 1 to it. And that gives us 4. Well, the next term's not 4. It's 5. So we got an issue there, okay? Just like 1 was not the first term here, 4 is not the third term there. So this worked for a little while, but it didn't work thereafter. You can see on A, it worked for every single one. Okay, rewatch the video, guys, if necessary. It's only 10 minutes out of your life, and if it means the difference between actually understanding it and not understanding it, it's 10 minutes well spent. If not, I will see you tomorrow. Have a great night.